Assalamu alaikum wa rahmatullah. Today I'm going to be presenting about full waveform inversion. This is seismic wave imaging. Before we dive into the presentation, I'm going to go through go through the content of this presentation. I'm going to start with background study, and then I'm going to go through the problem statement. After that, I'm going to show you how full waveform inversion works. And then I'm gonna share with you the recent major advances and discoveries, and also the current debates. And after that, I'm gonna conclude and recommend. And then you're gonna see my references and how I created these slides. So seismic inversion is converting seismic reflection data into quantitative properties, describing oil and gas reservoirs. FWI also estimates subsurface properties by matching observed and modeled seismic waveforms. Properties include velocity, absorption, Q, and reflectivity. This improves seismic imaging for Earth's subsurface insights. So the problem statement is that conventional seismic imaging techniques often face limitations in resolving complex geologies structures, leading to suboptimal imaging results and potential misinterpretation. So FWI, which is full wave form inversion, presents a promising solution by leveraging the entire seismic waveform to generate high resolution velocity models. So how it works is here. So as you can see, FWI refines subsurface models every time you refine the subsurface models. So it begins with an initial velocity model, and then FWI simulates seismic waveform based on that initial model itself, and then it computes the gradient of model parameters to minimize differences between simulated and observed data. Then the iterative process continues until convergence, and then from there it yields a final velocity model representing subsurface geological structures and seismic velocities. So as you can see in the diagram beside it, this is the process. You start with a model, which is a velocity model, and then you go through the forward modeling, simulated data, and then residual and gradient, which is the combination of observed data and then simulated data, and then you update the model. Then you have a final model. If it doesn't work, then you have to you go through the iterative process of going through all the forward modeling and everything in a circle again. Next, we're gonna see the recent and vast advancements and discoveries. One of them is the overlapping data input and computation, which is ODIC. This is a new method that makes full waveform inversion better by doing two things at once, which is calculating and reading data. Another one is multi-parameter images. FWI can now create detailed pictures using different types of data. This is like having a more detailed map of what's beneath the subsurface. Which is more resolution in general. So, and also then the last thing, which is major and recent and in discoveries, that is that distributed storage computing. This is a way of using different computers to store a process of and process a lot of data. Since FWI deals with a lot of data, so this is a way to store all these data in one place. It's like a team of computers working together to handle big tasks for FWI. Next, we're gonna see the current debates. So FWI can sometimes arrive at multiple solutions that fit the observed seismic data. Researchers are debating whether additional constraints or data types are needed to ensure a unique solution for the Earth's subsurface structure. So, if computationally FWI is expensive. So especially for 3D problems, there is ongoing debates about developing more efficient algorithm and utilizing high performance computing resources to make FWI more practical large-scale application. There is discussion also on how to effectively incorporate prior geological information into FWI processes. This could potentially improve the accuracy and robustness of the inversion results. So now we come to the conclusion and recommendation. So FWI is a highly useful and complex geology, and for useful in complex geology, and based on the recent advancements in technology, it's only going to be improving. And also, we can recommend that by working together and collaborating in results, and by executing FWI correctly, we can achieve more accurate data, more accurate results, and increase the accuracy of FWI. Thank you very much. And this is the references, as you can see. And thank you.